All right, everyone. Hopefully this is working okay. I had some technical difficulties last time, so I'm trying a few new things this time, and we'll see how things turn out. And if you're watching this later, then, well, we'll still hope things go smoothly. So basically, I'm just going to be going through the extra bonus review that I gave. The first review is totally sufficient and should be just fine. However, I just think that this is probably another good one to go through, and it's a chance for you to kind of see some of the work in action as well. So hopefully this will help out. If you have questions along the way, type them into the chat. I am trying some new chat settings, so if for some reason they don't come through, just try. Then you might just have to ask your questions later, or come talk to me at a different time. You could also just post your question to Google Classroom. I do have all of the Google Classroom pages open, so hopefully chat comments will be coming through. But if for some reason they're not, I would just try posting your question to Google Classroom, and then I can kind of help you out from there if that makes sense. So getting into the first one, what we're basically going to be doing there is we're going to be, as I search for my pen, there we go. We're going to be plugging in numbers for X. Okay, so those are really just two different problems. The biggest thing to remember for both A and for B is when you're plugging in numbers, first make sure to use parentheses. Okay, so I'm actually showing the plugging in step for both A and B. Second, order of operations say exponents go first. So I should actually be squaring that -3 first to get 9, and then multiplying by -2 to get -18. And then down here, I should be squaring 4 first to get 16, and then multiplying by -2 to get -32. So order of operations definitely still apply there. For number 2, what you're going to be trying to do is you are going to be you're going to be plugging in for both those numbers and then using multiplication to combine those things together. Okay. So for example, for A, you're going to be doing -4 squared times -2 to the third. Again, order of operations will still apply there. So you'll square -4 first. You'll cube -2 second. Oops, I wrote -2. Not helpful. Should be -8. And then you'll be multiplying those together. And you will get 128. -128. For A. And for B, same exact thing. -2 squared times -3 cubed. You are going to get 4 times -27. And that is -80 and 28. So that looks like a -108 to me. So there's our first two. Once we get past that, now we're going to get into all of these numerical exponent rules. Okay. So let's check those out. So what we're going to be doing first here is we're going to be multiplying multiplying these two expressions together. What you have to remember is the rules for coefficients, so the 3 and the 5, are different than the rules for exponents. We're going to be multiplying the numbers because it's a multiplication problem. So 3 times 5 is 15. We're going to be adding the exponents, and we're going to get x to the 12th. We're going to do the exact same thing for number 4, but the most common mistake is after we get that -36, from multiplying -4, -3, and the other -3, is a lot of people put y to the 12th, but it's actually y to the 13th. Because if you count your y's, you've got 8 here, you've got 4 here for 12. This one counts as a single y. That's actually like y to the first over there. So we should actually get 36 y to the 13th. Okay. Next, here we're going to distribute that squared. again, you're distributing the exponent to the exponent. So in the first case, when I distribute it to the -3, I'm just writing -3 squared because it didn't have an exponent. So I'm just giving it a 2 exponent. When I distribute it to the x to the 4th, since it already had one, my rules tell me to multiply exponents there. So I should get x to the 8th. Same thing for the y at the end. Then I should just get y to the 2nd. When I square -3, I get +9. So I get 9x to the 8th, y to the 2nd. Moving on to my division rules. Here, I'm going to be dividing numbers, and I'm going to be subtracting exponents. Okay, so I get 4x to the 12th, y to the 5th. So I divided my 48 and my 12, and then I just subtracted my exponents on my x's, and I subtracted my exponents on my y's as well. Okay. Next, distributing exponents, I get x to the 6th over y to the 12th. Notice how I just multiplied exponents. I didn't actually change the location of anything or do anything like that. Nothing at all. I really just simply multiplied my exponents together, and that's all I did. Okay. What you're going to notice now is on this next one, we have parentheses around a pretty specific area. Okay. So we have parentheses just around the top. So both of those should get that 8 exponent, both that x and that y up top. And then the y squared on the bottom should stay the same. I shouldn't be distributing my exponent there because it was not in parentheses. Okay. What I should be doing instead is now subtracting the exponents, but just on my y's. Okay, so I'm like canceling 2 of these with 2 of these, and I get x to the 8th, y to the 6th. Number 9 is kind of then asking you to put what we did together, what we just did in number 5, okay, together with what we did in number 6. So you're going to distribute the exponents first, and then after you distribute the exponent, you're going to have to then subtract exponents, okay? So I'm going to distribute here. Ooh, I'm pretty sure I meant that to be a y right there. Sorry, guys. That should have read. I'm going to rewrite this one. If you did it with the 5 in there, it's probably going to turn out a little bit different. But that definitely should have been a y. Yep, I meant y to the 5th, not just 5. My fault. So if you're watching this later, maybe take a pause and attempt this on your own. I'll kind of go through this one a little slowly because I had a typo. So again, you're distributing that 5 exponent. You should get 2 to the 5th, x to the 20th, y to the 25th. And on the bottom, we should get 2 to the 3rd, x to the 6th, y to the 9th. Notice how I didn't multiply 2 and 5. I wrote 2 to the 5th because, again, anytime you're distributing an exponent, it should just go to the exponents. Now you can just do exponent subtraction. So I'll get 2 squared. I'll get x to the 14th. And I'll get y to the 16th. So I get 4x to the 14th and y to the 16th. Looking at some questions, Nathan asked, do we have to write the answer to number 7 in fraction form? Not necessarily. You could have also written x to the 6th, y to the -12th. But if you're going to use y to the 12, you can't just put that on top with the x to the 6th because it was in your denominator. So it either has to stay down there or it has to become a negative exponent. That's a really good question. Looking ahead on the next page, here's where we potentially get into negative exponents. So for numbers 10 and 11, the most straightforward way of doing those is by just simply doing exponent subtraction. So I'd get, for example, x to the -6 on that one, a to the -4, b to the -6 on that one. That's just one way of handling things. Okay. Another way of handling things though is by like canceling out x's or canceling out variables. So I could cancel 6 of these with 6 of these and leave x to the 6th in my denominator. The issue is I can't just leave a blank numerator. So what you have to realize is in this case, canceling is really just dividing to be a 1. So I should stick a 1 in my numerator then. So like an alternative answer for number 11 would be 1 over a to the 4th, b to the 6th. Either of these answers is fine, and you certainly do not have to put both. Either of those would be totally acceptable. Okay, so you can use the negative exponents or you cannot. It's entirely up to you. For number 12, I strongly recommend that you initially write like this. 3 to the negative 3, x to the negative 12, y to the positive 9th. Okay, so basically what I'm telling you is initially, I would just make sure I did my exponent multiplication and specifically write 3 to the negative 3rd. The biggest thing on this test, especially when we're dealing with negative numbers, this is one place where things go wrong. 3 to the negative 3rd is the same thing as 3 to the 3rd, but in fraction form. Negative exponents are division or negative exponents are fractions. So you need to turn that into a 1 over 27 or a 1 divided by 27. Okay. You do not have to do anything with the negative exponent on the x, but you could if you wish. For number 13, this is a little bit of a tricky one in that we've got some positive exponents, some negative exponents. So there's a couple ways that you could do it, and I'll actually show you both. The first way is just straight exponent subtraction. Okay. So what you could do is you could do this. You could do 10 over 40 and make that 1/4. You could do r to the 8th over r to the 12th and make that r to the negative 4th. So you could subtract exponents there. And then you could subtract your exponents on your s's too. So be careful though, you're doing negative 9 minus negative 18. So that actually turns into positive 9. That is one way of handling the problem. If you just don't like negative exponents at all, remember what you can do is you can kind of switch where they are and make them positive. You can use that whole idea of dividing by the reciprocal to make them into positive exponents. So you could change that s to the negative 18th into s to the positive 18th in the numerator. Same thing with the s to the negative 9th. Now you can just do this with like exponent cancellation. Okay, so you can get rid of the zeros there. And you can cancel 8 of those r's there with 8 of those there. You can cancel 9 of those there with 9 of those there, and you would end up with s to the 9th over 4r to the 4th. That would be another way of doing it. Again, you don't have to do both of those. Either of those is totally acceptable and totally correct. Okay? All right. Next thing's next. Distribute exponents on number 14. So you're multiplying. This one's a little bit weird in that we have the x's and the y's seemingly in separate fractions. But what you have to remember is when you're multiplying fractions, all you would really do is multiply your numerators and multiply your denominators, and they would become one fraction anyway. So you can still cancel. Oops, I should have made that an 8. 8 of these with 8 of these to make x to the 13th, and 6 of these with 6 of these to make y to the 26th. Still a fantastic way of doing things. Okay. So I'm noticing, I'm going to go back and look at a couple questions now since we've had a couple things. Alec said, what was the one thing we said we shouldn't do on the test? That was right over here. Make sure that 3 to the negative 3rd or anything to a negative exponent is a fraction. Okay. Don't turn into a negative number. Okay, leave it a fraction. Okay. And I kid, I of course won't be super mad at you or anything, but I just know that over the years, that's been one of the more common mistakes I've seen. So just make sure anytime you got a negative exponent, you're turning that into a fraction. Okay. I think Sonia asked, why didn't that sign on the X in problem 12? I'm not exactly sure what your question is, but just looking back at number 12, remember you're multiplying by a negative number. So like it's -3 times -3 to make +9, -3 times +4 to make -12. And then you're doing 3 to the -3rd. And again, to do that, you're just saying, okay, well, what's 3 to the 3? That's 27. But it's a negative exponent, so it's got to be division. Okay? Okay. Scientific notation, last bit. What you're doing in those first two is you're trying to figure out where would I move the decimal place, or I'm sorry, where would I put the decimal place in that number to make it a number between 1 and 10. So for this one, I'd put it right here, and I would change my number to 2.3. But now what I'm asking myself is how would I go from 2.3 to 230,000? Well, I would multiply by 10, and then I'm just figuring how many times do I multiply by 10? That's 1, 2, 3, 4, 5 times. So I make it times 10 to the 5th. Those are the exact same number, just written in different ways. Okay. Looking at it from 16's perspective, the difference here is I'd make it 2.5, but I don't really want to multiply by 10, right? If I multiply 2.5 by 10, I'm going to turn it into 25, and then again would be 250, and then I'm getting bigger numbers. To get smaller numbers, I want to divide by 10. Remember, though, that negative exponents are fractions. So I would actually want to divide it by 10, 1, 2, 3, 4, 5 times. So I'm going to make that a -5 exponent to indicate that I'd be dividing by 10 5 times. Number 17, it's a little bit weird. It looks like it's in scientific notation, but it's not, because that first number has to be between 1 and 10. So instead of writing it as 60, I'm going to write it as 6.0. And then what you have to realize is this. I want to now adjust my number to make sure that I haven't kind of changed anything. I don't want to change the value of that number. I'm trying to make sure it stays the same value. So I made that 60 go down. I need to make my exponent go up to balance that out. So I'm going to make that a -5. Looking back at a couple questions. On number 9, how did you get 2 squared in the answer? Okay, so I'll circle back to number 9 really quickly. I think that was that the previous page? Yep, that was right at the end of the previous page. I know which one you're talking about. So what I did is I wrote in mine 2 to the 5th and 2 to the 3rd. So I distributed those exponents to the 2's, and then I did exponent subtraction. Now, you don't have to necessarily do that. Okay, I'm going to change color so we can see how it would look a little bit differently. You could have simply written 32 x to the 20th, y to the 25th over 8 x to the 6th, y to the 9th. And then you could have divided 32 and 8 and gone straight to the 4. That would have been a totally other acceptable way of doing that too, and would definitely make sense. Someone asked, will you have a section on the test where we have to write a number in scientific notation into standard notation? No. Okay, last section. You are multiplying and dividing. So our rules here stay exactly the same. When you're multiplying, you're going to multiply numbers, and you're going to add exponents. 3 plus -6 is -3. When you are dividing, you're going to divide numbers. So 4 divided by 8 is 0.5 or a half. And -2 minus -6 is +4. Same thing for number 20. Divide the numbers, 8 and 4, get 2. And 6 minus 8, get -2. That's the basic, okay? Multiply the numbers, add the exponents when you're multiplying, divide the numbers, and subtract the exponents when you're dividing, okay? However, we now have to go back and make a correction on both 18 and 19, because while our answer is numerically correct, it's not in scientific notation, okay? So again, you don't want to change the overall value of that number. So when you change your 20 down to 2.0, increase your exponent to balance that out. On number 19, when you increase 0.5 to 5 to make it a number between 1 and 10, decrease your exponent to balance that out. On number 20, we have a number between 1 and 10 to start off with, so it's really no big deal for us to just leave it that way. It's already in scientific notation. Okay. If you have any other questions or anything like that that pop up, let me know. I'll be around tomorrow morning. I'll be around during recess too. So if you have any last minute questions, especially if you're taking your test tomorrow, feel free to ask me then. And if you're taking your test on Tuesday, you can let me know at some point tomorrow that you had some other questions. Okay. Hopefully this last bit of review was helpful, and good luck on tests over the next couple of days.